actually make a data object and then share it. And then, it doesn't just exist in the book.
Okay, today we're going to take what we talked about yesterday in terms of turning full models into components. So we're going to apply it to this transfer line that we did, and then look at kind of some of the implications of that. The final piece in the methodology has to do with event priorities, and that will come up with the next computer assignment I ask you to do. And then, time permitting, I might talk about these things like modeling if conditions in event graphs, because again, just like for loops, having a state transition that has an if in it is technically not legal in event graphs. Again, why? Because. Okay, so if you remember, we took the multiple server queue model and then turned it into two components, in which one was the arrival process that we had already kind of done, and the second was just the server component piece. And that only modeled the part of the system that processed the service part. And in a similar way, the transfer line component takes the transfer line model that we did yesterday that was that started to look a little bit like spaghetti, and just kind of makes it a bit simpler to only have the part of the system that processes the parts, as it were. It doesn't model the arrival. So just as one of the things that motivated turning the multiple server queue into two components was the fact that we noticed, or some of us noticed, that the arrival process pattern was something that kept appearing again and again. Now, that doesn't mean that arrival process will necessarily be part of every model. In fact, you're going to encounter some models where that isn't an example of that. But for the situations we're looking at now, we're not modeling the arrival of these parts. Okay, so the parameters are going to be the same as for the transfer line. And again, you don't have to write all this down, because this is all, the slide is in the upload thing, so, Just as with the multiple server component, the transfer line component has everything except for the interarrival times. So if you remember, in the transfer line model, we had the T sub A sequence, and here we don't, because we're going to say, okay, somebody else is going to do that, and that's comparable to what I consider the programming virtue of that's not my job. And we're going to have the same state variable, so just the same kind of issue. And so the component looks like this. In other words, all we do is we just focus on the part of the model which deals with processing these parts as they wend their way through this sequence of stations. And one of the things about this is that because we have parameterized the number of workstations, this model will work no matter how many workstations we have. So this will work for 1, 2, 3, 4, however many we have. That's the advantage of parameterizing these things. And again, in a larger sense, it's analogous to in programming where you went from scalar variables to arrays. If you find yourself in a program having pretty much the same kind of thing, except a 0, 1 and a x0, x1, x2, and then it's important to maybe take a step back and say, well, maybe an array would be more effective way to capture what's going on here. Why? Because with an array will typically handle how the number of items in the array is like a parameter. That one variable, the array, can handle however many items that you want here. And a similar thing is going on here, both with the parameters as well as the state variables. So again, here, because all of the parameters are arrays, or all of the state variables are arrays, the pattern for initializing them is this. And this, at first blush, may look like an arrival process, but the main difference, there are two main differences. One is that there's no time on the scheduling edge. It's a zero. It just keeps spinning until it runs out. And it's important to have this condition because otherwise it'll keep spinning forever. And what'll happen, and it's one of the things that these models are just as stupid as other programs in that they'll do what you tell it to and not what you want it to. So if you somehow forget this condition, and in fact, if you forget to implement it in it, then you get this sort of weird phenomenon. When you go to run the model, it just sort of sits there. And what's happening is it's spinning at zero. It keeps scheduling the next init event at time zero, and time never advances beyond zero. And so that's something that can happen if you forget to put this condition on. So you see the difference between this component that would just kind of it's exactly the same in terms of the way that it's modeled here. So the arrival with an argument of I is the arrival of a part to workstation I, and that causes the queue at workstation I to increase by 1. And in every case, there is a there's a consistency between the scheduling edge and the event that it schedules in terms of the parameters. So this event, arrival at station I, schedules a start service at station I, and it has to pass its argument I. It's important to understand that these two I's are very, very different syntactically. And it's like the difference in syntax when you invoke a method versus when you define a method. If I define a method with an argument of an integer, say I, that's a formal argument, in that I can only put a variable there. Now, if I call it and I have a variable called I that I've set to some value and I invoke that method, then that is a very different, that is an expression, or at least that single variable is an expression. So I could pass I could pass I plus 1, I could pass I to the fifth or whatever what my language will allow. So it's important to understand the syntactic difference between a formal argument on either a method in a program or an argument on an event in an event graph, and the thing that calls it, which is an expression. And that is not completely apparent in these scheduling edges, but it is once we do this. So it's clear, well, it's not clear that I by itself is an expression. It is 100% clear if I say I plus 1, that can only be an expression. That can't be a formal argument. Okay, and so the logic is exactly the same, except now we have a little bit of a problem. And the problem is that if you remember, the arrival process produces an event called arrival, but with no arguments. Arrival. So it produced an event with no arguments. And back when we had the complete model, we could schedule our first arrival and pass it 0. But now we don't have that ability because it's not there. This arrival event with no arguments is not a match for the arrival event with an argument. For two events to match when we're listening, there has to be an agreement of the name and there has to be an agreement of the arguments. And if either one of those is missing, then there's no match. So if the transfer line component were to hear an arrival event with no arguments, it would look and say, I don't have an arrival event with no arguments. And so it would completely ignore it. So does that mean we're screwed? Well, no. It just means we have to do a little bit of extra work. So the arrival process by itself cannot work because it schedules arrival events, and the transfer line component needs arrival events with an argument of I. So there's a mismatch there. So how can we overcome that? Well, we need to create a new type of arrival process, and in a way kind of motivated by our full transfer line model, we need an arrival process that can schedule an arrival event with an argument of I. And that's just a very simple one like this. It's it's just a minor extension of the arrival process. And so if we just have a component that just adds one additional scheduling edge to the arrival process, we have two choices. We can either write one of these from scratch, and it's simple enough. I mean, this is almost the minimalist type of event graph that you could possibly have. And it's not rocket science to do one of these, but nevertheless, we're lazy, bless you, or at least I'm lazy. And the programming virtue of laziness says if you've already done something, then don't do it again, because if you try to do it again, the chances are you'll screw it up, at least if you're me. So the lazy way is to subclass our arrival process. So once we have a concept of a event graph component, we can introduce the concept of a subclass of the arrival process. In other words, we have the arrival process which does its thing perfectly. It doesn't completely meet what we have here. And so instead of just writing the whole thing from scratch, what we can do is we can say, well, we're gonna simply subclass our arrival process component and simply add this to it. And in other words, if we override our arrival event, and we need to make sure that we call the super version of that, and then we just simply add another scheduling edge, which will schedule an arrival passing it a 0, and that will, for our transfer line component, that now the transfer line component will hear this event, the arrival event with an argument of I. And so if we have an instance of one of these, and we have an instance of the transfer line component and it's listening, then it will work. It will work because this component is scheduling an arrival event with an argument I, and the transfer line is going to hear that and then process it from there, whereas it will not hear this one. It'll actually hear both of them. So what will happen is it will hear, and actually conceptually this is what's going on here, it will hear the arrival event with no arguments, but then it'll look and say, I don't got that, so la la la, I'm not hearing you. But then it will hear the arrival process with an argument of in this case an integer, and when it hears that, it's going to then execute its state transition, and then schedule the other events like that. Now, that may seem a bit abstract to you. You would implement that in SimKit. And in the process, let's see, this is another model I'm working on, so let's get rid of that. Okay, so I have created a repo called MV3.302 class code. You all have access to it. Let's just sort of verify that. Okay, so everybody has access as a reporter, which means you should be able to clone it. So would you clone yours? And I've called it class code so that you can have it in your NetBeans next to your project and hopefully be able to tell the difference between the two. And don't try to push to this one because you don't have permission to, so it'll just kind of mess things up. So how do you do that? Well, you should have a link to this. You can sort of clone with HTTPS if you have a public-private key with secure shell. That works with this. It only works if you're on the if you're on the network here. For some reason, they've closed port 22 for off. Anyway, so normally HTTPS. So we're back in NetBeans. If you go team, git, clone, and then paste that in, you should be able to use your credentials, which NetBeans has saved with your access token. Let's see, are you going to let me do that? Okay, so, and that should open, you should be able to just open the project. And let's see, resolve problems. SimKit could. All right, so the.
What do you click?
Where you click team and then you click
Team
clone.
and what?
All right, let's do that again. Why? Sorry, just. All right, let's try that again here. Okay, so team, git, or if you have more stuff in there, just it should say remote. And then paste it in.
Remote?
Clone.
Clone.
No.
See, a pull is when you already have checked out and synchronized your local Git with the GitLab Git. A clone is when you do it for the first time. And after you do the clone, then you do a pull anytime there's a change on the server. And okay, I think kind of okay. And if you these different versions are okay, so and then okay, so darn it. Okay, so for some reason. Drat. This.
It says SimKit library cannot be found.
Yeah, you're the one who messed me up on this. It should have been done as a local library. Okay, so how do we do that? We will create one. So basically, if you get that, then you just have to recreate.
We have to add the library manually.
Yeah, you have to kind of do that, and normally,
We don't have to do that, right? You're reinstalling SymKit?
yeah, you're gonna have to do that just because of the way this was structured. And see, yeah, normally it should have been yeah, I think, I had, yeah.
Can we walk back through
We
that?
walk back through everything, so we kind of, yeah.
Okay, this is all recorded. You can kind of go back and do this. I want to show you the example. Okay, and the situation is, okay, so here's my arrival process, which this is, so basically what I'll do is that after each assignment is graded and sent back and with my complaints on it, then I'll put my solution in here. But for here, what I want to show you is I want to show you this. I want to show you how to extend okay, so what we're doing is we're doing this. So here's our arrival process. We're going to extend this with our, I'll call it arrival creator. And what's the design of this? The design of this is just this piece down here. So no parameters, no state variables. Very simple event graph. But it utilizes all the stuff in the superclass. Now, in order to do that, if you remember, Java does not give you constructors in your subclass. You have to explicitly do those. So we need to explicitly give our constructors and okay, so if you the arrival process needs this inter-arrival time generator in order to work, and so we need to, well, in this one way is to pass it. The other issue, and the convention is that all event graph components also have a zero argument constructor, and that's mostly for when you are instantiating these from a data file. That's one piece. The other piece is that it also makes it conform to the Java Beans specification, which requires that every Java Bean have a zero argument constructor. Okay, so again, the design is we have an arrival event with an integer I. So the way to take an event and implement it in a SymKit model is you take the name of the event and you put do in front of it. This is it's a bit of an anachronism. I mean, it's something that when I wrote this, if I were to write this today, I'd do something else. But this is what it did, and because there's a lot of code out there that uses this convention, I'm kind of stuck with it. Now, in this case, not in all cases, we want to call the super. Normally, you never invoke an event method directly, normally. This is the one exception. This is the one and only time that you're allowed to directly invoke the one of these do methods. The reason for that is that if you try to invoke it directly, you're bypassing the event list, and the event list needs to be processing these events. The reason why it's allowed here is because the event list is already processing this method. And so all we need is we need the logic in the super event. That isn't always the case. There are situations where we actually completely override the state transition in the super event. But what we need to do is we need to schedule an arrival event, and it is case sensitive with 0 delay and passing it an argument of 0. So here's the where are you? Okay, so we need to schedule an arrival event and passing an argument of 0. And this is how we do it. So if there are no arguments, then we just have the name of the event and the delay. If there's an argument, then we put it at the end. And then again, the design says we have an arrival with an argument that's an integer, and it does nothing. Again, this subcomponent has no state variables in addition, or parameters in addition to what it already has. So the full thing has a parameter, which is the inter-arrival times, and it has a state variable, which is the number of arrivals, but they're all inherited from above. And again, it never hurts to have this little override thing. So how can we test this? You always want to test it out. And the way to test these out is to run it in verbose mode and listen to the state transitions with a property dumper. So we need a random variate, which is our inter-arrival time generator. And you don't have to give it the same name when you're calling it from here, and all of the random variates we get from our random variate factory. And in this case, I'm going to say, give me a gamma distribution with parameters alpha and beta. Most of the standard probability distributions are available in this way. Not every single one, because there are far too many to put in, but it has all the standard ones. Okay. Okay, so now we've instantiated it, but now the first thing to check is that your parameters have actually made it inside. And so the way to do that is right off the bat, we're going to print that out. And what all we're looking for is to make sure that this gamma got in there. Okay, so it did get in there. Okay, why is that important? Because if we forget to do this, and it's easy enough to do, if we forget to do that, then what we get is null. Okay, so, and this is something which, if you do this for a while, at some point you will experience. So we put a parameter in, and in this case it was null, or if it was a number, it came up 0 or something like that, instead of the one that we had. So again, before I go any further, I need to fix this. And okay, now why didn't it do it? Well, it turned out I'd forgotten to put this in. I put it in, and then now it works. Okay, so now I can kind of go forward. And just the simple way to to basically, if you run it by hand, as it were, but instead of running it by hand, we're running it in a way that, that the computer does all this. It's going to run forever unless I stop it, so let's stop it, maybe after 20 time units. Again, just the reset call. What that does is it does a couple things. It clears the event list if there are any lingering events from a previous run. It resets sim time back to 0 if it had been something else. And then it calls reset on all of the sim entities that have been instantiated. And that's all it does. So now the event list is just kind of sitting there until I call start simulation. And you might be wondering, why are there two calls here? And the reason, which we'll encounter a little bit later, is that sometimes there are things that you need to do before you start simulation, but after you do reset. And we'll see what that's about. So what I'm looking for here is I want to see arrival events with no arguments. I want to see them being scheduled, and I want to see the arrival events with an argument showing up. Okay, so let's look at this. So when we start the simulation, I have the run event here. I have when I say stop at time, what it does is it actually puts an event called stop at the time that I have. So that has been done, okay? So the order, if there are more than one run events, they'll happen in, whatever. There's only one. So again, at this point, the event list logic is exactly what you were all doing by hand. You take the earliest scheduled event, in this case run at time 0, you quote advance time. Sometimes the time advance is 0, that's legal. So we move time to 0, execute the run event. Okay, what does that do? That invokes the arrival event. It schedules the first arrival event, doesn't invoke it. Okay, so, all right, so here's our first arrival event. And then this is what we're looking for. It schedules this arrival event, and then notice that there's an argument which is listed in curly braces here. So you see the difference between the arrival event with no arguments and the arrival event with an argument, which is listed here.
What does the actual 0 represent?
The 0 is the argument that we passed right here. So if I were to pass another argument and run it again, then that's what would appear. Okay, but in this case, that's not going to work for my transfer line because I need a 0. Okay, now how do I know that this is really going to get heard by the transfer line? So I need, I haven't implemented the transfer line, but what I can do is I can implement just a little test guy. And just for testing purposes, I'm going to do it as an inner class. And it's just going to be a sim entity base, just like we had before. And all this is going to do is implement an arrival event with an argument of I, and now in this case, what I'm going to do is I'm going to fire an index property change and just say what I heard. Now, how do I know that this is actually happening? Well, here's how I set that up. Oops. Okay, I'm going to instantiate one of these guys. And then the way that I get it to listen is I say to the arrival creator, add sim event listener to the arrival listener. And again, just like if you remember when we added an action listener to our JButtons, we said, the JButton instance, add action listener. Now, instead of add action listener, I add a sim event listener. Now, how do I know that it's actually being heard? Well, this simple property dumper and if I instantiate it with a true, then what I can do is it will list each one. Now this will test to make sure that this thing is actually hearing it. And so when I run it, okay, now notice that all this had was just that one arrival event. It didn't have a run event or anything, so there's no extra run event happening there. So again, as before, we schedules the first arrival event with 0 arguments. When that arrival event occurs, again, the simple property dumper says, your number of arrivals goes from 0 to 1. And it schedules the arrival event with an index of 0. And now the simple property dumper says, I heard that, and because it's firing an index property change, what it does is it gives you the index and then the value in this particular case. Okay, so in other words, the listener is hearing that, and the way that we did that is we added it as a sim event listener. So you see that there are 2 different listeners going on. One is the sim event listener, which causes the events to be heard and thereby processed. And the second is the property change listener, which is how state transitions are announced to anybody who is interested in hearing them. And what you'll be doing tomorrow is utilizing a couple things. You'll be using the sim event listener to implement the multiple server queue as a component with the simple server. And then you'll be using the property change listener together with a stat object to compute certain measures. And the way that the statistics object is going to work is it's going to listen to these property changes, property change events as they get fired, and then update their counters. So instead of doing everything by hand, as you did in the first assignment, the statistics object will do all the work for you. And the reason that's important is because none of this would be useful if we didn't have the ability to collect statistics. The reason that it's separated is because if you embed the statistics into the model, then you're stuck with whatever statistics you have chosen to collect embedded in the model. And there have been many cases where either myself or one of my students have been trying to run a model off the shelf from somewhere, and they wanted to collect some data or statistics from the model that the model had not deemed necessary to provide, and they were stuck. And so with this loose coupling of the property change listener, if there's some statistic that that you're interested in the model, all you need to do is listen to the right variables, and then it will happen. Okay, so what, I will commit this. But what I use. Bless you.
Excuse me.
And then push it. Okay, so now if you have cloned this already and you now do a pull, then you will get what I just did, which I have not commented yet. After class, I will comment it, and then, you know, because I don't want to be a bad example.
No,
Pardon me?
we're gonna use the code that you use.
No,
Because I
no,
didn't know it.
no, that's just for your own edification.
Okay.
Okay, the last thing that's going to kind of come up, and this is really just a this is something which very rarely occurs, but when it occurs, it can be sort of an issue, and that is priorities on events. Because there are 0 delays, there are sometimes a situation where you have multiple events that are occurring scheduled to occur at exactly the same simulated time. Now, normally, that's not a complete issue. Normally, it's you want your models to be immune to any particular order of the events occurring. But sometimes, especially within a component, there are situations where there's a potential for a problem because you want one event to happen before another, and they just by chance have been scheduled to occur at exactly the same time. So if I have 2 events, and one is scheduled 0.0000, you know, 10 to the minus 20 before the second one, then it'll happen first. Any amount within the precision on the virtual machine will happen if it happens to be scheduled first.
What precision does Syncade use? Is it floats or doubles?
It uses whatever the virtual machine is, which I don't know the exact value, but it uses whatever double precision gives you. But sometimes just by chance you will have an exact time tie, and in that case, you can say, I want this event to happen before any other event that's scheduled at exactly the same time. So it's the secondary tiebreaker. The first priority is scheduled time. If there's an exact match, then the one with higher priority happens first. And it turns out that in the multiple server queue, what we want to do is we want to make sure that our start service events occur before the other ones. And the reason for that is, if we use continuous random variables, then the chances of an exact time tie between, let's say, an end service event and a start service event that had been scheduled from the arrival event is negligible. And by negligible, I mean in over 20 years, it's never happened once. The problem comes in is that there could be situations where, let's say, if the inter-arrival time generator was a discrete random variable and the service times were discrete random variables, then there's the possibility of exact, in other words, an arrival could schedule a start service at exactly the same time as an end service. Normally you don't want to do that. Normally you don't want to use discrete random variables as your times in this. But just in case, then just the final thing is to say that the start service event, in this particular case, is scheduled with a higher priority than either arrival or the end service event. So if by chance either one of these events, arrival or end service, happen to be scheduled at exactly the same time as the start service will happen first. And that in the handout for the next computer assignment, I show you how to do that in SimKit. Okay, just some final little event graph stuff. Like, if I want to model an if, again, when you're writing code, of course, there's nothing to prevent you from putting an if inside of an event method. But in terms of pure event graphs, that's not something that's allowed. If I want to do that, then I do that by scheduling events like this. So if I have something like, if I'm in a situation where I say if B, else C, then here's the way to do that. I simply have some event that's going to schedule him, and I schedule B with the condition, and I schedule C with not the condition. And so this is how you would implement an if using event graphs. And what about else if? Well, if I have if B, else if a second condition C. So the first if is B. Okay, if I is true, then I invoke B. I schedule B. I don't invoke, I schedule. If I is true, not I is false, so that this scheduling edge does not happen. If I is false, I don't schedule B, but I schedule C. But then, now if the else if is this other condition II, and if that's true, then I'll schedule C. And if I want something sort of like a case, a switch statement, kind of like a switch statement, I can have, here I have 3 Booleans, 1, 2, and 3. And whichever one is true, that one will be scheduled. So in this particular little pattern, let's say if I is true, but 2 and 3 are false, then only B will get scheduled. If an II are true and 3 is false, then both B and C will get scheduled. And if they're all true, then they'll all get scheduled. So this gives you enough capability to capture the if stuff. Okay. Shown how to turn the transfer line model into a component. We dealt with the issue of trying to get this arrival event with an integer I scheduled by having this design and then having the implementation be this lazy way of utilizing what we've already done in the arrival process. And then finally, I showed you how to implement it very simply, I think, by subclassing what's going on here. So we won't be doing, it'll be a while before we encounter this. What I'm asking you to do next is only exploiting this. In other words, you have your arrival process that you've already hopefully created. And then what you're going to write is you're going to write the multiple server queue component. You'll hook them up like this, And then you'll also instantiate some simple stats, which will allow you to get some statistics out of it. So all of that should be released. If not now, then shortly.